Craig. Yeah. Okay, so just to be sure that we have these videos in this recorded. Okay, so now let's go to question number 4. So we have a simple interest rate for a year is equal to 12%. And the trick here is a compounding period, and they say that this compounds each 3 months. Okay, so then find the compounded interest rate for 1 month, then the simple interest rate for 6 months. So what you always need to remember, guys, is that the simple interest rate equals the compounding interest rate when there's only one point in which these two guys cross. When is if this is time? How do we call this period here? This is my simple, this is my compounding. Guys, when the simple equals the compounding interest rate, when?
At the comp.
Exactly. This one here is called the compounding period. Got it? So basically means the following. So if you have this type of questions of time transformations that include simples into compounding interest rates, what you need to first look for is for your compounding period. Remember that if there is no compounding period, the default is 1 year. Got it? So if I tell you guys, my simple interest rate for 1 year is 12%, find the monthly compounding. You immediately will go to assume that the compounding period is 12 months. Okay, by default, if I don't give you the compounding period, if you don't find the compounding period, is by default 12 months or 1 year. But as soon as here we have the compounding period that is equal to 3 months, so what I need to do before solving this question, what I need to do? What I need to do, guys, is to transform my rate into the compounding period. So basically what I need to do is, if it's simple, I need to continue working with simple, but I need to look for the simple 3 months, correct? So my simple 3 months is going to be very simple. 12% is for 12 months, and I'm looking just for 3, so this is equal to 3%. So why this number is very important? Because this number at the same time is the compounding 3 months. Do you agree, guys?
Yes.
Yes, and once you have this, so you have now the simple and you have a compounding. So once you have the compounding, any period, you can simply do a time transformation of compounding. So this is going to be equal to 1.03 to what power? Minus 1. What power goes here? Guys, what is the power? This rate here is for 3 months. So this 3% corresponds to 3 months. So what goes up and what goes down? I'm interested about the 1 month. What goes up?
1.
1.
And then 3 in the denominator.
Perfect. So can you tell me, can you give me this number? Guys, can you give me the number, please? Guys, come on. What is this number? You need to be sure that you are able to compute, use your calculator, guys, because the exam is going to be with calculators, not exam. The quiz is going to be full calculators.
0.99%.
0.99%. Someone confirm?
Yes.
Perfect. Okay, now for this one here, if it's simple, I don't care about the compounding period, right? So what I can say here is simply, this is 12%, this corresponds to 12 months, and I just need 6 months. So this is equal to 6%. Okay. So the compounding is useful only if you're going to be transforming simple to compounding or compounding to simple. Got it? questions about number 4? No? No questions? Yes.
Please explain that P again, please.
Yes. So remember that we are having, if this rate is simple interest rate, and you are requested another simple interest rate with a different period, you see, this is 1 year, this is 6 months, you don't need the compounding period. You don't care about the compounding period. What you do is you do the simple transformation or simple into simple. What you say is, I know that 12%, this one, corresponds to 1 year, 12 months. And my question is, I want to find the one that corresponds to 6 months. Simply multiply times 6, then divide and then multiply, and this is your simple 6 months. Okay? So you simply do the time transformation that corresponds only to simple interest rates.
Thank you.
My pleasure.
So I had a question, Professor.
Yes, please go ahead.
So for the example that you, for example, 3 that you did, I believe it was last Tuesday, it was the same. Hold on, let me check. Right.
Wait, it is not related to these questions, so we can answer questions about the class in what follows, just to keep some order, okay?
Okay.
Yeah, but remember your question. Once we finish this exercise, we're going to answer questions that you have. Okay, guys. So what is the interest rate paid for all these periods? So you had a loan for $10,000. You don't pay anything for 6 months, and then at the end of the 6 months, you pay $10,750. So what is the interest rate that you have paid? How do you compute that? I will write simply I, and this I corresponds to 6 months. Do you agree, guys? Because it's 6 months. So how do you compute the interest rate? Guys, no doubts, guys, no doubts. Why do you know what? There is not a single class in which someone has simply jumped into the pool immediately. Why? Come on, an interest rate, if you have a future value and you have a present value, that's all information that you have. How do you compute the interest rate?
You use the same equation you have there on the left, future value equals present value
Yeah,
1.
yeah, but you know what? You don't even need that. Remember, imagine that I transform this graph and I give you something like that. $10,000 and 10,750. Imagine if I give you a graph like that, how do you compute the interest rate?
Oh yeah, you're just going to say the 10750 divided by the 10,000 over the 10,000.
Minus 1.
Minus
Right?
1.
So what you say is basically 10,750 minus $10,000 divided by $10,000. So this is it. So don't worry if you have months in between. The only thing that these numbers here are useful for is to identify the periodicity of the rate. Got it? So here, what you know is that the formula is going to be the same, of course, minus $10,000 divided by $10,000. Okay, the formula is the same, but here you assume that this is one period. In here, you are assuming that I give you the graph. So you know that this interest rate corresponds to 6 periods. So this number equals what? 7.5%?
Yes, 7.5%.
Exactly. So what is crucial here, guys, is that this 7.5% corresponds to 6 months, correct? Because that's the period that have passed. So this is your rate. You know that the loan rate is 7.5% for 6 months. Now the question is the following: what is the average monthly interest rate? So what is my question? My question here, guys, is asking you, guys, give me the interest rate for 1 month. How do you compute the interest rate for 1 month knowing the interest rate for 6 months? How do you do that?
You use the time transformation formula.
Exactly, guys. So it's so simple. to the power of what minus 1? What goes up, what goes down?
1 goes at the top.
Yes.
And, 6. There's 6 periods.
And 6 here. That's it. Can you give me this number, please? So remember, guys, when we are talking about compounded interest rates, okay, the average doesn't mean divide this by 6. Okay, that's terrible because you're assuming that this rate is a simple interest rate. We're using a compounding interest rate. So what we need to do is we need to use basically the geometric transformation, okay, or exponential transformation. What is geometric transformation? You need to use this formula. Okay, someone can give you the number, guys.
1.21%.
Someone can confirm?
Yep.
Perfect. Perfect, guys. Questions? No questions? Okay, 2 minutes to save, to copy and analyze and think. And if you have questions, otherwise we continue with at least three more questions.
Prof,
Yes.
yes, I just want to ask, like, with number 5,
Yes, number 5. Yes.
if
Here.
like that
Sorry,
in
I don't hear you very well. Can you repeat that, please?
like you take, I can hear me. Okay.
Yes, I hear you. I hear you now. Yep.
Yeah, so if it like in 3 years, then maybe you take like you take another further loan like for like $200. So it's still going to follow like the same formula, but now what will be the denominator? Is it gonna be 10,000 or 10,200?
Oh, I understand. I understand. So you say that for here, for example, we receive 2,000 more, right?
Yeah. Yes.
Yes. Okay. So in that case, this gets more complicated, and then in that case, you cannot using this. You cannot use summing up this formula. You cannot do that because remember, what will happen is that if you have, for example, 2,000 more here, okay, we need to have what is the growth of rate of this $10,000. So normally you have an interest rate going on here. Got it? So you need an additional piece of information. That's what I'm saying. So imagine for the first 3 years, you have a 1%. In that case, what you do is you move this $10,000, 1%, 1%, 1%, and then you have the value, the future value of this $10,000 here. You sum with the $2,000 here, and then you have a number here. Do you agree? Now, for this number here, then you can apply. You can do this divided by this. Now, if you assume that this $10,000 didn't account for any interest rate, that should be weird. In that case, you can sum this $10,000 to $2,000 here, and then you obtain $12,000, and then you compute your interest rate. Got it? But that should be insane. Normally, when you have this type of loans that you have multiple disbursements, so basically you need to have the interest rate that corresponds per period. Make sense? Yep.
Yeah, it makes sense, Prof. Thank you.
Pleasure. Okay, guys. So let's do a couple of another questions. Let's do a couple of questions now. So let's assume that okay. Oh, let me change this color. So let's assume, guys, that you need $10,000 for 3 months. Okay. And you have the following alternatives, guys. You have one is offering you the simple 1 year is going to be equal to 10%. you know, B is going to be a simple 1 year that is equal to 9%. And this one here is compounding monthly. Then you have another alternative that is a simple 6 months that is equal to 5.5%. This is compounded annually. And then you have another one that is a simple 15 days that is equal to 0.35%. Okay, which one do you select? And just for convention, guys, let's assume, let's work, all your answers should be in compounding 3 months. Just to standardize the result. Okay, so this is 6 actually.
Prof, just explain to me quickly, what do you mean you need 10,000 for 3 months?
You need money. So you go to a bank, or you go to 4 banks actually, and then you ask them, okay, I need $10,000 for 3 months, working capital for your business, for example. Okay, and bank one tells you, okay, I will lend you this $10,000 for 3 months. So the payment is going to be at the end of 3 months, and I will charge you 10%. The other one tells you, oh, I give you a simple of 9% compounding monthly. The other one tells you, I charge you a simple 6 months, it's 5.5 compounded annually. And the last one tells you, oh yeah, I can give you an interest rate of 15 days that is equal to 0.35. So basically you need to pay, you want to select the one that asks you for the least amount of money, maybe, or least interest rate. So that's what you're trying to find. Make sense? esposa. Entonces dice que no puedes mandar el email. ¿Tú por qué? Francisco, tú manda el email entonces, Francisco. ¿Por qué? ¿Por qué no? Okay, let's say 3 more minutes, guys. Please try to solve this. Ready? Two more minutes, guys, and then we solve it. Okay, so let's start working on this. So this is a pure time transformation, guys. So you should be very efficient on this already. So if it's a compounded 10% 1 year, so I just want to put everything in 3-month terms. It's going to be 1.1 to the power minus 1. So it's going to be 1/12, correct, guys? Guys, do you agree?
Yes.
Yeah, so what do you get here? What do we get here?
$0.78.
Sorry, what? 0.78%?
Yes.
Yes, confirm, someone to confirm? Guys, someone can confirm?
Yes.
Perfect. So B, well, I have a simple, I need to go into a compounding. So what I need to do first of all is I need to find, this is annual rate compoundly monthly. So I need to find first of all the simple 1 month. So this is going to be 9% corresponds to 12 months. I just need one month. Okay, so this is equal to what?
Prof, just one question.
Yes.
Number A, why is it 1.1 1 over 12? Isn't it 3 over 12?
Oh, completely right. Because we want 3 months.
Mm.
Completely right. It's 3 over 12. So what do we get here? Can you please check this? Thank you. Completely right. So what do we get here? Just be sure it's 3 over 12. The other one is going to be 9 divided by 12, basically.
I got
So, yeah.
what?
Sorry, 0. What?
I got 2.4%.
Yeah. Oh, yeah, 2.4%. We're talking about percentage points.
Yeah,
Someone to
also
confirm?
got that.
Yeah, perfect.
Yes.
Yeah, confirm.
2.4%. Good. So now, remember, this one I cannot transform directly to 3 months because I need to go first to the monthly period. Okay, so that's why I'm doing this. So this is equal to 0.75%. And as soon as the simple is in a compounding period, this is also equal to the compounding interest rate for 1 month, correct? Then if I have 1 month, I can go to the 3 months compounding. This is going to be 1.0075 to the power 3, correct? And I obtained 2.27%, more or less. Someone can confirm this one?
Yes, confirmed.
2.27%. Perfect. Now let's go to C. The same, I need to have a compounding annually. So I need to find a simple 12 months. I know that 5.5% corresponds to 6 months, and I need 12. So this is equal to 11% annual. And so this is going to be equal to my compounding 1 year. Correct, guys? If I have the compounding 1 year, I want to transform this one into the, oh, wait a second. So this is 3 months. Okay, so this is good. What is the 3 months here? It's going to be equal to 1.11 to the power 3 over 12 minus 1. Agree with me?
It's not 6 months.
I don't hear you. So, okay, let me, perhaps I try to understand what you were saying, but I couldn't hear you. So basically what we're saying here, I have the rate that is a simple for 6 months, but my compounding period is annual. Okay, this is very strange, just did it for this exercise. So what I need to find, first of all, is the simple 12 months. So I know that's 5.5 is equal, it corresponds to 6 months. I need the 12 months. So this is 2.2 times 5.5 is 11%. So as soon as this one corresponds to the compounding period, this is also equal to the compounding interest rate for 12 months or 1 year. Once I have this compounding, the remaining part is easy. If I have the 12 months, I simply transform 1.11 to the 3 over 12 minus 1, and then you should obtain 2.64.
Yeah,
Correct, exactly, 2.64%. And then finally, guys, the last one is easy. If I have, it's compounding, so I can do compounding. I want the compounding 3 months. If I know that this is 0.0035 to the power, what? Minus 1. What do I write up? Guys, what I write up you know, this period, this corresponds to a period of 15 days, correct? So if I have down days, I need to have above days. 3 months corresponds to how many days?
90 days.
90.
90 days. Okay, remember, it's 3 months. And by convention, guys, we are going to be using the 30-day convention. Okay, so what do you tell me? Can you give me this number, please? Come on, guys, we need to do this
I
faster.
get 2.11%.
2.11%. Someone to confirm?
Yeah.
Perfect.
Yes.
So which one is the best one for you guys? Which one is the cheapest for you? 2.4, 2.27, 2.64, 2.11. Obviously, this number here, right? Guys, make sense? So basically, if you are looking for the cheapest loan, you're going to go with loan number D. Understood? Guys, it's clear?
Yeah.
Perfect. So, okay, so let's go to the, can you do this very quickly? The net present, well, we can do this very quickly because otherwise we're going to take a lot of time. How do I compute the net future value, guys? What I do is I compute all the cash flows. I move the cash flows to the future, right? So the opportunity cost is 10%. So let me move the opportunity cost somewhere. Let's move this to a different place. So I will write this here. My opportunity cost equals 10%. Okay. So my 200, if I move the 200, 1, 2, 3 periods, this is going to be 200, 1.1 to the power 3. The 500 is going to be 500 to the power 1.1, times 1.1 to the power 2. And the 300 is going to be times 1.1, got it? So these values are going to be, so let me see, 200 times 1.1 power 3. This one here, please you check, okay? This is 266.2. 500 times 1.1 power 2. This is 605. And 300 times, oh yeah, come on. This is 330. Okay, so what I've done is I've moved all the cash flows to the future. So my future value is going to be 330 plus 605 plus 266.2 plus 800. So my future value is going to be equal to 2001.2. Someone to confirm? Guys, someone to confirm? This is my future value of the cash flows. Do you agree with me or not? Okay, so what I need to do in order to find the net future value, I need to move this 700 into the future. So we move this into the future. It's going to be simply 700 times 1.1, 1, 2, 3 to the power 4. And I will put a negative because this is the investment. So it's 700 times 1.1 to the power 4. This equals minus 1024.87. So my net future value then is going to be equal to 976.33. Someone can confirm this value? We need to have the exact numbers, guys, because I want you to replicate these exercises. Someone can just...
Yes, confirmed.
Perfect, excellent. Okay, so what is my decision rule, guys? If the net present value, if the net future value is what? Is larger than what? Than 0, right? Do the investment. Okay, so this is my decision rule. In terms of net present value, what I will do is I will compute first the net present value. The net present value is going to be minus 700. So what I do is the reverse. I need to discount each of the cash flows. So 200 is going to be discounted by 1.1. 500 is going to be discounted 2 periods. 300 is going to be discounted 3 periods. And 800 is going to be discounted 4 periods. Okay. So this should be, can you please verify 666.85 more or less? Help me verifying this one here.
Yes, confirm.
Perfect. So we confirm this one here. Excellent. So how do we show that these two guys are equivalent? Well, we can do any of these two things. I move the net future value to the present. So what I can do is net future value to net present value. So this is simply 976.33 divided by 1.1 to the power 4. And you should obtain 666.85. Can you please verify? Or you can go a net present value to net future value. What you do is you compound. So we can go 666.85 times 1.1 to the power 4, and then you should obtain 976.33. So you need to confirm these values.
Yeah, confirmed.
Confirmed. Perfect. So this is what is called the equivalency. Okay, perfect. And use Excel to compute the internal rate of return. So let me save this one here. Yeah, let me take a picture to this so I can remember the numbers. Where's my... Oh, I don't know where I put my cell phone. Okay, 200, 500, 300, 800. Okay, let's take a look. So let's do this in, let me open Excel first. So let me share Excel. Okay, let me create another file here. So my cash flow was minus 700, 200. What was the other number? 500, 300, 800, something like that. Can you verify this, please, guys? Is this correct?
200, 500, 300, and 800. Yes.
Yes, perfect. Excellent. And then from here, guys, what you do is you simply do the internal rate of return, IRR, and then you select cell A1 to cell L5 and enter. So here we go, 41%. Just to remember. Okay. Everyone understand this? Hopefully, you know how to do this very quickly too. So we get 41% using Excel. So my internal rate of return equals 41%. So what is my decision rule? If my internal rate of return is larger than what? Guys, larger than what?
0.
What?
Opportunity cost.
Opportunity cost.
Opportunity cost. This
We do
implies
the-
we do the project, correct? So
Yes.
this is my decision. Okay, guys, I think that with this review, you should be okay for the exam. The only thing that you need to remember, guys, is in terms of the Excel file, remember that you have this net present value internal rate of return file that you need to replicate. You need to be sure, guys, that you send me this file before the exam, okay, next Thursday. And you need to be sure, guys, that you have this one here. If you go in tab number or that the label is Quest Exam 1, parentheses 2, you need to be sure here, guys, that you have not only the table, but also the graph. I will ask questions about this result. So once you do this one here, please analyze this one, think about this one here, because at least a couple of questions are going to come regarding to this page. So you need to have this page open for the exam. Make sense?
You say next week, Thursday?
No. This Thursday, because the quiz number 1 is this
Okay.
Thursday.
Okay.
Okay. Okay, guys. So I think with that, I'm done with this one here. So we can continue moving. We can continue moving now, guys, into what I was telling to you. So let's continue here. Let's continue with the class. So what we have been doing, what I gave you on Friday, guys, is something that is called IOUs, okay? And IOUs are crucial instruments for finance. It's basically something like, the easy one is to understand is a mortgage. So you have a C0, and then you're going to have a bunch of payments. A bunch of payments like this, okay? So, and from here, what we said, okay, what is interesting is that my payment, and we have done the mathematics, guys, equals to the principal. So let's call a present value that multiplies 1 plus I to the n times I, 1 plus I to the n minus 1. Okay, so this part here was called the factor. This number here is given. N is the number of periods that we're going to have the loan, and the payment is something that you're going to be paying constantly. And what I also showed in the previous class, guys, is that how to build what is called a payment schedule. Okay, and this is regular, guys, when you have a loan, a mortgage, a car payment, a car loan, etc. And the payment schedule basically had this form. So you have the period, well, or time, if you want, you can say that amounts here. Then you have the principal. And remember, the payments are divided into pieces: capital and interest, and finally the payment. So for this particular case, this method here, guys, when the payment is the same, so it's always payment, so the payments are the same. This method here is called the French method. Today or next class, we're going to learn about the American method. So what happens here is that at the very beginning, so if we take a look to the principal goes decreasing like that. Okay, so this is my principal. My interest at the very beginning are larger than my capital, and my capital catches up soon. Okay, so this is my capital. This is my interest, okay? Not in the same dimension, but okay, this is more or less what happens. So at the very beginning, the interest corresponds to higher, it's going to be larger, and then the interest starts decreasing. And the capital starts smaller, and then basically it starts increasing, okay? So this is what I show you in the video that I shared with you on Friday. Okay, so let's go to the Excel, and it's easy to understand this one here using Excel. Let me share Excel. Oh, just 1 minute for you to take a look and copy. Okay, so let's go to Excel. Not you. Do you see my screen, guys?
Yes, you have 4 different tabs. You're on the amortization tab, right?
Oh yeah. This one here now. Do you see the present value, etc.? Do you see this 9,000 at the beginning?
No, I don't. I don't see 9,000.
No.
Yeah. I need to be sure now.
Yes, sir. Yep.
Excellent. So this was the first example, guys, that I gave you in the previous video. Is simply saying, you know what, I have my present value is $9,000, so I need a loan for $9,000. The annual interest rate is going to be 26.82. I will pay this in 8 months. So the first thing you need to do, guys, is to transform the annual interest rate into a monthly interest rate. And what you do is you simply use our common formula, time transformation. You see? Let me put this one. Yeah. So if we use our time transformation, it's going to be 1 plus 26% to the power 1/12 minus 1. So this is my monthly interest rate, correct? Then the factor, guys, is the one that I gave you, I times 1 plus I to the power n divided by I plus I to the power n minus 1. And then you simply multiply your principal times the factor, and then you obtain your payment. Right? Also in Excel, guys, you have a command that provides you this already. Instead of completing everything, you simply do payment. This is the interest rate, needs to be in percentage terms. B3 is the number of months, and B1 is the amount of money that I owe, okay, or my loan amount. And I put this negative just to have the payments positive. And then you can see the results are exactly the same. You have also here the formula, guys, when you want to replicate this stuff. Now, how do we build our schedule table? Basically, this is what we do. So we have 1, 2, 3, 4, 5. I have 8 months. I start with 9,000 principal. My interest is what you need to, well, the payment, you simply copy the payment all over the place. It's going to be this B6 and B6 every time. So that's why it's $, $. Then you copy down. And my capital, guys, is a residual value. So this means that always is going to be the payment minus my interest gives me my capital. So, and the interest is simply how much money I have used from the bank for first month, $9,000. How much I need to pay? I need to pay the bank monthly, 2%. You multiply 9,000 times 2%, you obtain your $180. Right? So the next principal is going to be simply my principal minus my capital payment gives me my principal. And after that, the model works beautifully now. What you need to be sure, guys, just to be sure that you are correct, is that the last principal must be equal to the capital payment. They must be equal because the next period is going to be, the debt is going to be equal to 0. Right? And this is what I was telling to you. Interest go decreasing, capital goes increasing. So it started at 180, ends up being 24. It starts at 1,048, ends in 1,200. And the payment never changes. This is the French method. Got it? Questions? Questions, guys? Guys, do you have questions?
No, not at the moment.
Okay, excellent. You need to let me know, otherwise I really don't know if I'm moving too fast, too slow, I don't know.
Prof,
Yes.
I'm hearing you say the payment never changes, so it's the same throughout for each period, for
Yes.
each month.
Yes.
Is it a rule, or how do you treat a situation where maybe in 1 month they decide to pay extra, so
Yes,
they make
we're going to do that. Yes. We're going to do that. Exactly. What is next is exactly trying to answer what you're asking. Yes.
Okay,
if you do prepayments, if there are changes of interest rates, etc., we're going to do this exactly in this class. We're going to be covering that. Okay.
Also, Prof, in South Africa, when it's a mortgage, the
Yes.
payment actually goes down. If it's a car, we do it like this.
Yes.
But if it's a mortgage, the payment goes, as the capital is paid off, the payment actually goes down.
Yes, it can be. So you are using the American method. We're going to do the
Yeah,
American method
okay,
in,
cool.
in, I don't think this class, next class. Yes, but that's completely right. So payment can go down, but capital stays constant and the interest rate is the one that moves a lot. Yes, I will do this in next class. Okay, we're going to cover that. Okay. Now, let's go. So what happens, guys, and I think, well, this is the same. Yes, this is important. So let me change to my screen. And I will do one very simple example that I'm pretty sure you know. Imagine, guys, that you have the following, okay? Let's take this as an example. What is called effective cost of capital. Okay, so imagine, guys, that you have the following. You receive 100, and then you pay a fee of $1. So this is a fee. And you need to do, let's say, 1, 2, no, just let's do 1 period, just to make it simpler. You just have this one for 1 period. And then you need to pay, I cannot do this with 1 period, unfortunately not. Okay, so let's assume that you're gonna have 3 payments or 4 payments. Okay, so you have PMT, 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 and PMT. So just to make it more realistic, let's assume this is 10,000. And then that you pay $100 as a fee. Got it? So first of all, guys, what you need to realize is that to compute payment, to estimate the PMT, the payment, you do not use the fee. Okay? So you simply assume $10,000 and then you compute your payments. Okay, of course, you're going to have an interest rate for, imagine, is a 2% per month. Assume that, well, it's not assume, it's 1, 2, 3, 4, and it's going to be 4. Okay, in order to compute the payment, guys, you ignore the fee. Okay, so let's do that. So let's go again to Excel. And let me create a new we'll call this example 2021. So what I told you guys, let me copy from here, all this part here. Yeah, perhaps can copy this one here. So ignore for a couple of minutes, guys, this part here. We don't have this part here. Okay, so what I'm telling to you is I have $10,000. Follow me. Yeah, I don't have the annual interest rate. I have immediately the 4 months, and I know that this is 0.02, so it's 2%. So my payment is going to be, and I have a commission, we said is, yeah, it's too much. So let's do 1% flat. So 1% is going to be 100, correct? That's correct. So in order, guys, to compute my payment, if you can see, the payment has nothing to do. So my factor and everything has nothing to do with a commission or the fee. Okay, this number here is independent of the commission or the fee, guys. Please remember that. Okay, once you compute that, then you start doing this stuff, and then as soon as you have 4 periods, so basically this part disappears. So this is your table, right? The payment is going to be constant. The capital increases, interest rate decreases, and the last principal equals the last capital payment. So this is my cash flow. Make sense to you guys? So step number 1, when you have fees, commissions, etc., you ignore them. The the payment is free of that. We don't consider that. Now, when do we use the fee then? Why is it useful? When we want to compute what is my effective cost of capital, so this one here, in that case include all expenses, all fees, commissions, etc. Got it? So this implies that for that one here, this is going to become 9900, and then you have your payments. And then you find the effective cost of capital. Guys, how do you find the effective cost of capital? What technique do we use? What technique do I use, guys, in order to compute the effective cost of capital?
Is it the WACC?
No, the weighted average cost of capital implies that I have two different interest rates. In this case, I only have one, it's a loan. We use what is called, guys, as internal rate of return. Do you agree? This is a cash flow. It has only one inflow and many outflows, so that's okay. So the technique, guys, is again the internal rate of return. Make sense? Okay, so let's do that. So I will show you this simple example, and then we can move to the more complex example. So now I can move this one here and see what I will do. Take a look. So my present value, so in order to compute my effective cost of capital, so my present value was this. My flat was simply 1% of this $10,000, $100. So my net is 9,900. And the payments that I have done are 2,626. Do you agree, guys? In order to compute my cash flow, so this cash flow here is a cash flow that I have drawn here. So you see this 9,900 and my payments here. That's what I have. This is my cash flow that I built in Excel. This one here. Once I have this cash flow built, what I do is I simply do the internal rate of return technique. Of course, I don't, this is for a previous example. So you simply do internal rate of return like that. Make sense? So remember that 9,900 is positive and the payments are negative, just to be sure that, that there is a positive and negatives. And then if you analyze this one, so okay, here guys, remember what was my interest rate? My interest rate was 2%. So what is my effective interest rate? Because I have paid 1% commission flat, it jumps to 2.4154% per month. Do you agree? So this is a number that is crucial for you because you're not paying 2%. You're paying more than 2%. You're paying more than 2% because you have a fat fee of 1%. And also you are not paying 3%. You see, perhaps you decide to sum 2% plus 1%, 3%. No, forget about that. It's not correct. You have a 2% monthly, and this 1% basically influences the first payment. And so what is your effective cost of capital? You end up paying 2.41% per month. Make sense? So this is the effective cost of capital, guys.
Prof, just a question there.
Yes.
On the IRR, why do we use
2%?
0.02?
Yeah, this is a guess. You don't need to do that. Excel always asks you a guess if you have a very huge number of observations. But no, I never use it. Even I had at a given point in time, I think I have around 10,000 rows. I didn't enter any guess, and it works.
Okay.
Okay.
Also another one. So in this case, the annual calculation there isn't really relevant because we didn't have an annual.
Yeah, exactly. I gave you
rates.
directly, exactly. I gave you directly the 2%.
Okay.
Yeah. Okay, so let's do this now. Let's do this example. That is longer, you see, 36 months. The idea is exactly the same. So I have $45,000 principal. I have an annual of 25%. I have 36 months to pay. I need to compute the monthly interest rate. You know how to do that. It's simply transformation of this one here. You compute the factor, you compute the payment. Okay, and on top of that, you have a flat of 2%. So remember, that flat commission is simply a percentage over the principal. Recall that this one here doesn't enter in the computation of the payment. So we ignore this for a time being. You compute your payment, you create your table. Yeah, the payment is going to be the same forever in this case. And what you need to remember is always that the last principal equals to the capital payment. And if this is true, so your table is correct. Now, the next step is to compute the effective cost of capital, okay? So what indeed I'm paying? I'm indeed paying, what is that, 1.8%. So if you put this in percentage terms, 1.896%. No, you're paying more because you have a fee. And then in that case, you know, the present value is this one here. You need to subtract the fee, the 1%, sorry, 2% of $45,000 is 900. So what your net cash flow inflow is 44,100. You know that you're going to be making 36 payments of 1,736. So that's why they are negative numbers. And then you have your cash flow here. You do your internal rate of return, and then you obtain your real or effective cost of capital. So effectively, you're paying each month 2.0213%. Do you understand, guys? Do we understand this?
Prof, just quickly again, the concept.
Yes.
So the effective, it becomes like a return almost to say, okay, no, this is a loan, but it says that you're actually earning.
No. You're not earning.
Paying
you're
more per earning. I know.
Yes.
Yeah.
Yes.
Because I mean, you're looking. It says annual effective.
Mm-hmm.
But then you're comparing it with what we have on the monthly, and then
no.
Okay,
wait.
no. Sorry, I'm looking at the wrong one. So yeah, you have that monthly comparing it to the monthly. Then you have the yearly comparing to the yearly.
Yes, right.
But it's not the same as the transformation you made between the annual and the monthly here on the left.
No, it is
sort of like a return figure.
No. It is. So remember, I have an annual rate. So let me move this. Okay, so this was my annual rate. This is the interest rate that the bank is charging me, 25.28% per year. If you transform this into monthly interest rate, you see the formula is the same. It's 125 to the power 1/12. So this is my monthly interest rate. So the bank tells me, hey guys, you know, you're going to pay me 1.89% per month. So this is what they advertise you. I'm pretty sure if you go to a bank and get a loan, they tell you, okay, it's going to be 5%. Perfect. But then they are going to write and this always happens, they are always going to charge you something more. Sometimes here in USA, they call points. You know, they tell you, you know what, I can give you a lower interest rate, but you need to pay me up front 1 point, for example. What is a point? It's a fee. Basically, that's it. They also are going to charge you for management. They are going to charge you for a bunch of other things, right? And these amounts of money normally are small amounts of money, but you know, it depends on the amount of money. It depends on your loan, that you feel it or you don't feel it. Got it? Now, when you do the internal rate of return, so basically the technique is called internal rate of return, but the technical name of what we are doing here, as soon as we're considering the PV minus the flat rates, commissions, etc., is called effective cost of capital. So this is the meaning of this is that this is the interest rate that indeed you're going to be paying per month. Make sense? So per month, that is 2.02. It's not 1.89. You need to remember that. It's simply higher. Now, if you don't want to do the comparison month to month, this month to this month, what you need to do, if you want to compare this, that is a yearly interest rate, you need to transform this one here, that is a monthly interest rate, into annual interest rate. And take a look, the transformation is exactly the same as we do. This is going to be 1.0202 to the power 12 minus 1. You see the simple transformation. This is a monthly to move it into annual rate. And now you can compare this 27 with this 25. So basically the bank tells you you're going to be paying 25% in average per year, but indeed you are going to be paying 27.14%.
Okay, and if the question doesn't state anything about simple and compounding, we know that it is compounded and it's annual.
Wait a second. Yes, yes. You know that the simple interest rate, you know, as I show you, it is disappearing, you know, because it's simple, but you can do a lot of tricks that the people don't realize, and you can be making more money than the people is knowing they're paying to you. Remember we did this trick? I can give you a 2% simple annual compounding daily, and this 2% is going to become perhaps 3%, and you don't realize that. You see that there are a lot of tricks. That's why now, guys, in USA at least, bonds were valued using simple interest rates until 3 years ago. Just 3 years ago. Now everything is compounding. Okay, because compounding, even though it's more tricky to understand for a common person, not you, of course, you are studying. But if you talk about in microfinance, for example, guys, poor individuals looking for a loan, and someone comes with a compounded interest rate, so it's going to be almost impossible for them to understand what we are doing. Okay? So that's why the simple is still being used in Latin America, Africa, in microfinance institutions. And we have found that. And we have found also a lot of tricks that these guys do in order to make more money. And of course, they don't tell the clients, or they tell the clients in very small letters that no one reads. And they're basically ripping off these guys. Make sense? By default, we are going to be using compounded interest rate. So all this part here, unless I tell you guys, this is my interest rate that is simple, compounding, blah, blah, blah. But in general, no. In general, we'll provide you numbers like this. Make sense?
Yeah, thanks.
Perfect. Okay, so now let's start going with the prepayments. And this is something you were asking. So now let's assume the following, guys. Let me remember this example. I always forget this example. So, oh yes, at the end of the 6th month, I want to pay all. Got it? So I simply have my 6th month and I want to pay everything. So what I do, how much money do I need in the 6 months? Remember, this was a loan for 36 periods. How much money do I need to have at the end of the 6th month? That's my question. How do I compute this number here? So do you know, guys, that how much money do you owe at the beginning of the 6th month? 40,414. Agree with me? How much you need to pay for this period? Oh, I need to pay interest 766. Got it? But I need, if I want to close this loan, I need to have 40,414 plus this 716. So how much more money I need to have, or how much money I need to have at the end of month 6? I need to have the sum of these two guys. Make sense to everyone?
Yeah, I think it's what we call a balloon payment.
Yes, it is a balloon payment. Exactly that. It is a balloon payment. Now, note that just talking with my South African students in the past, they told me that when you have a balloon payment in a mortgage, for example, you are going to be penalized for early payment. Yes. I don't know if you have changed the rule. Yes. Yes. In USA, for example, in USA, the prepayment is not penalized. So if you want to prepay at any time, at any point in time, you just prepay, no penalties. I remember your colleagues from South Africa, they were saying that sometimes it's very harsh. Sometimes they were saying you need to pay an additional 1 or 2% if you want to pay early as a punishment for early prepayment. Right?
Yeah, so, because the bank loses money.
Yeah, well, yeah. You know what? That discussion was here in the 70s in USA. And you know why they are not charging anymore? Because there was the one that defended the case, it was USA, no, I think it was New York versus the banks, something like that. The lawyer of the bankers, sorry, the lawyer that was representing New York is a very famous guy here in New York, a very interesting lawyer. What he was saying is basically, wait a second, you're charging, and indeed we understand and we agree with you that what you do is if someone gives you the money back in 6 months instead of 36 months, so what you are doing is you are losing money, okay? Because you planned this money was going to create so much money in 36 months. However, you have an advantage that you're a bank. So you are a specialized entity whose objective is to lend money. So for you, even though it's a kind of it's a harsh, but you have more means, you have more power to, recolocate, re-lend this money to other people. The individual has not that power. Do you see that? The individual, what if you are going to charge him a very high penalty and he cannot pay the penalty, he's going to be forced to keep the loan not for 6 months, but for 36 months. Do you agree? So there is asymmetry on relationship. There is asymmetry on power. So the banks are more powerful, and the bank's goal or business is to create loans. So that's why this was the defense, and in USA we won. That's why, guys, now there is no prepayment penalties at all. You can prepay whenever you want, no issue. You can prepay 10%, you can prepay 20%, you can prepay everything, the balloon payment. Got it?
We do have new instruments though now.
Oh,
That's
great.
like, it's a flexible bond that you can pull out and put in as much as you want to a
Yes.
certain degree. So that's
Yeah.
a new product.
But this is a product that is logic. Do you agree? Okay.
Yeah.
Okay, guys. So this is another example. What I did is, okay, so you know what? Sometimes, and the people tell me why I should do that. Well, because you need to do it. If you decide to pay, imagine this example is the following. I am in the 16th day of the 6th month. Okay, and I have the money already. One way is to wait. You know what is the 16th? I wait until the 31st of the month and then I pay. Don't do that, because you're going to be paying 15 days more on taxes, on interest rates. It doesn't look a lot of money, but it's better to just spend that money in a beautiful restaurant that just pay to the bank. If you have the money, you're going to pay it immediately. That's what I'm trying to tell you. So if this is the 16th of the day, 16th day of the 16th month, so how do I compute? What is the difference here? Nothing. Here is the same. The only one that changes is this month, is this quantity here, the interest rate. I need to pay interest rate only for 16 days, correct, guys? Because that's what I'm saying. I'm going to pay the 16 days. So what I need to do is I need to compute what is the interest rate for 16 days. And take a look. It's very simple. What I do is I know that this is a monthly rate. So it's going to be to the power 16 over 30 minus 1. So this is going to be my rate that is going to apply only for the last interest rate calculation. So this number here is simply the amount I owe to the bank times the interest rate that corresponds to 16 days, and how much money do I need to have at the end of the day in order to close this loan. I need to have this money. How much money I indeed need to have, because I need to cover also the interest up to that period, is equal to the sum of these two guys. Make sense? And then by doing that, by paying on the 16 instead of by the end of the month, of course, it depends on when you have the money. So you're saving almost $360. Make sense? So if we're not talking about $45,000, we're talking about $450,000. Okay, so this starts growing. So that's why it's useful, guys, to pay whenever you can, whenever you have the opportunity to do that. Make sense? So this is the easy one. So now let's do with a couple of things. Take a look. So what I will do now is I will change the interest rate. So imagine that you get a loan, and the loan is an adjusted or variable rate. Okay, they tell you, guys, it's going to be fixed for a year, then it's going to change according to the LIBOR plus something, or to the prime plus something, etc. Okay? So it can change. And then imagine, let's do the following. So I start with 45 before moving. Questions up to now? Do you understand up to now? Guys, you get it?
Yes, thanks.
Yeah.
Perfect. Okay, so what I was telling to you is the following. So the first 6 months are the same. So I have my interest rate. My monthly interest rate is 1.89%, and my payment is 1,736. I do my payments, and then I receive at the beginning of the 6th month, because you need to have a 30-day notice, that starting on the 7th month, your interest rate is going to change from 25.28 is going to change to 28.59%. Right? So what this implies is basically that the remaining money, the remaining principal, is going to be based on a different interest. The number of periods is simply the 36 minus the amounts that you have paid, so it goes back to 30. And then you compute the same. So you have the annual interest rate, you have the monthly interest rate, the factor, and then your payment. As you can see, guys, as soon as the interest rate has increased, your payments now are going to increase from 1,736 to 1,789. And then that's it. If there are no more changes, you end up having here. Be sure that this number equals this number, and we should be okay. Got it? Make sense, guys? Do you understand?
Yes.
Yes, perfect. So let's do another one. Yeah, this is an interesting one. So let's continue with my previous example. Remember, the first 6 months was under this interest rate. The second, well, perhaps until month 20, this was my interest rate, so it increased here. And then imagine, guys, and this is what you were asking. Basically, what we have is, imagine that we are in month 20 and then we receive a bonus. Got it? And in month 20, I have $10,000. I have $10,000 I want to use as a prepayment. Got it? So what I've done in this case is, okay, I have $10,000, but I need to use the normal payment. I need to pay this amount of money. So what I'm left is 8,210. And I want to use this 8,210 to reduce my principal. Got it? So what I do, and just be careful here, is that you don't reduce the 25,000 minus 8,000. So first of all, you need to pay the capital payment. So it's going to be this number here is indeed in 2 stages. Regularly, it's going to be this minus this. So this is the new principal for 20 to the month 21st. Do you agree? What I'm doing is I'm saying, no, you know what? From this amount, I want to subtract this money that I have what I've done. So basically, what is my new principal? It's going to be 15,866. Okay, I don't change the relationship. It's 28%, 16 months. So I want to keep my 36-month period payment. And then what happens is that your monthly payment, as soon as you have done a prepayment, is going to decrease from 1,789 to 1,179. Make sense to you guys? Do you understand? Guys, clear?
Yes.
Perfect. Okay, good. Now, there is an option here, guys, because you know what, and this happens in the mindset of at least from me, I say, you know what, why I should, you know what, I already know how to pay this amount of money. I'm used to pay this amount of money, do you agree? So I don't want to decrease my payments from 1,789 to 1,179. So what is the option? What you can ask the bank, and the bank normally accepts that, is basically, you know what, I want to keep the same payment, but if I want to keep the same payment, what is going to change in here? You understand? If I want to keep the 16 months, my payments decrease from 1,789 to 1,179. That's clear. But what if you tell the bank, I want to continue, I've done my prepayment, I want to continue paying 1,789. So what is going to change here? The payment periods, right? So you're not going to be paying any more 16 months. You're going to pay less than 16 months. So this is the option number 2, and this is what we get here. So this was the same. I have, okay, so you hear me here. I have my 8,000 something. So this is my new principal. This is the regular interest rate. Oh, no, this is not the one. This one here. Okay, this is my 15, this is my 28. And what I want now, guys, remember that before in here, this one here was an estimated formula, right? I have my 16 and I compute this number here. However, when you want to keep the same interest, the same payment, what you do is you fix this number to the last payment or to the previous payment. I want this to be 1,789. Got it? My interest is going to be the same. My factor is going to be the same. However, what you need to realize, guys, is the following. I need to compute how many more months I will pay. The MATLAB, sorry, not MATLAB. Let me enlarge this one here. The Excel command is going to be NPER. We enter the interest rate. We enter the payment in a negative, just to have a positive number of months. And I have my principal, B39. So what this one is telling you is the following. What is this 9.92? Well, it's telling you that indeed you are going to pay 9 full months and 0.92 of a month. So this is this 28. We normally transform this into days. So this is going to be equal to 30. I have B41, so what's my B41? So I have 30 times 0.92. This is basically this, correct? And this one here corresponds to basically 28 days. So I will be paying, instead of 16 months that we have here, these 16 months, instead of having 16 months here, what I will need to pay only is going to be paying 9 months and 28 days. Got it? So we are not going to go anymore to the 36 periods here. We are going to reduce this one to 30 periods. And the only thing that you need to realize, all the cash flows continue as usual. Okay, this number is going to be constant, except for the last payment, because the last payment we have a lower interest rate that corresponds only to 28 days. This one here corresponds to simply how much money I owe to the bank times the interest rate that corresponds to 28 days. How much money do I need to have is the same amount here. How much money do I need to have at the end of the loan? I need to have the sum of these two that is equal to 1648.82. And that's it. Make sense? Guys, make sense?
Yes, Prof, we're giving you reactions. We see there.
Perfect. Okay, so if you don't have questions, guys, I think that the effective cost of capital. So this is a simple example. No question. I cannot show you a question from the exam, of course not. Yeah, and I can show you this one here. This is what I was telling to you guys. You know, we have done this. If we put together the capital, the interest, the payments, I do the cumulative capital. Of course, I start from 907 and I start accumulating. I need to have that total loan, $250,000 loan. And this is what I was telling to you guys, is that at the very beginning, perhaps I can enlarge this one here. At the very beginning, the interest rate is above the principal, the capital payments. And then after more or less 48 periods, we start going up more in capital than interest. Okay, so one trick, guys, that you need to realize, and it's really effective, is if you just do down payments, very small down payments per month, just to equalize this red into the green or put the red above, a little slightly above the green, can make this green decrease dramatically and can make this red increase dramatically. Okay, so these are the savings of prepayments. If you can do that, do it. Okay, don't keep your money in the bank making almost 0%. Just use that money to do prepayments. You have $500 more that you can use it. Okay, use it, guys. And this is amazingly how fast you can save 2, 3, 4, 5 years. I had a mortgage that was 30 years, and by just doing this for 10 years, I basically disappeared my debt in the 12th year. Okay, just if you can do it, guys. Make sense? Okay, questions? Questions, guys? So I need to do something more, and then we are going to do a couple of exercises with this topic. Questions, guys?
No, I don't have a question right now.
Okay, got it. Perfect. So let's go and let's do something more, and then we do exercises. We're gonna do one Excel more. Okay. So something that is extremely useful, guys, and I'm pretty sure you know how to do this already, if you put all the things that we have learned, is something that are called discounts. So what is a discount? Or sometimes we call it IOU discounts. So imagine, guys, that we have an IOU. An IOU is simply a document that tells that someone owes me money, right? So what it has, for example, I have someone is going to pay me $10,000, okay? And maturity, of course, you're going to have exact maturity days, but let's say in 120 days. Okay. This happens, for example, if you sell something to a retailer store, you sell beer. You go to the retailer store receives the beer, but they don't pay you immediately. They pay you in, let's say, 60 days or 90 days. I'm using here 120 days, okay? But they give you a paper that says, you know what, Walmart is gonna pay you $10,000 in 120 days. So this is a document, do you agree? So now let's assume, guys, that this document was signed on, let's say, 05/03/2021, right? And now we are on 06/08/2021. Guys, I use this opportunity to do the following notation clarification for our friends from South Africa. In USA, we use a month, day, and year. Okay, I remember having one exam, guys, with you, and that all the South Africans did arrive to a completely different result. And I was saying, why are you joking? That's easy. Why have you made that mistake? No, it was not a mistake. I think that someone mentioned that you say is the opposite for you. You have day, month, and year, or something like that, right?
Yes.
Guys? Yes. So be careful, guys, that we're going to be using in the class the USA method. Okay, we're going to use this one here just to play safe. So this is May 3, 2001, and this is June 8, 2021. Got it? So now you are here. Okay, you are here, and you have your corporation, and for some reason you need liquidity now. You need liquidity. I need cash now. I need cash now. Right? So what you can do, depending, of course, who has issued this loan, this document here, who's owing you money, you can go to a bank, and then you can ask to the bank, please, bank, I have this document. Can you please discount this document? And the bank is going to tell you, yeah, of course. But you know what? I will charge you. Okay, so my interest rate per 30 days is going to be equal to 3%, for example. Got it? Now, my question is the following. What or how much money you are going to receive in here? How much money you're going to receive in here? If you know that the bank charges a 3% discount, and they're going to give you the money here, how much money from this $10,000 they are going to give you at day June 8, 2001? The interest rate every 30 days is 3%. Go ahead, guys. Let's say 3 minutes to do this. Okay, 1 more minute, guys. Okay, so how this works. Okay, guys, first of all, I need to know when exactly is 120 days, correct? So I need to know the date here. I need to know what date is this one here. Agree? First of all, you need to understand how many days do we have from here to here. So I have, this is May 3, May has 31 days. So I have in May, I have 28 days. Plus June, I have 6 days, and sorry, 8 days. So up to here, I have 36 days. So how many days are left from here to here? So it's going to be 36 minus 120. So we're talking about 84 days. You agree with me, guys? That this is the clue. This is the number that you need to know. Why? Because in order to compute this one here, what I'm doing, guys, is technically, remember that the $10,000 are here. I will receive this money here. What I need to do is I need to do a discount. Why is it called a discount? Well, because we're discounting. So what is the value of this $10,000 in here, guys, knowing that the 30-day interest rate is 3%? So it's going to be $10,000 discounted by 1.03 to the power of what? What power I use here, guys? What power do I use here? Come on, guys.
Is it 30?
It is what?
30.
30, but remember, we need for 84 days.
Yes.
Okay, so remember, this should go a ratio again. 30 should go up, should go down, and what I need to go up is 84. You agree? Because I need the rate for 84 days, knowing that this one here corresponds to 30 days. And this is your discount. So your discount here is going to be basically equal to $10,000 divided by, you help me here, 1.03 to the power 84 divided by 30. Yes. So you verify this number. So this is data. This number equals 9,205.68. Someone to confirm? So this is this number. Guys, you agree?
Yes, Prof.
Perfect. Okay, so now there is something that is called a discount or bank discount. Okay, so the bank discount is the amount of money that the bank keeps for them. So it's very simple. It's going to be the principal minus what you get. This is my this bank discount. So how much money the bank is going to keep? It's going to be $10,000 minus 9205.68. So the bank will keep $794.32. Do you have questions?
Yes.
Yes. Go ahead.
So does it mean that the bank is going to loan you that $9,205?
Yeah, it is like a
now.
collateralized loan, yes. Because they have the
Um,
collateral is this document here, do you agree?
And I mean, at the end of the period, you're going to give them 10,000 back.
No. Well, there are two ways. There are two actually. Okay, so let's go a little more technical here. Yes. So let me put this here. So what happens is the following. So you have at the beginning a document that tells you. So imagine you were the one that sold to Walmart. Okay. Walmart is going to pay you in 120 days, $10,000. So if you don't need the liquidity, you simply wait 120 days and Walmart is going to pay you $10,000. Do you agree? This is the first case. Now, if you in June 8th, you need money, so you go to a bank, you give the bank, you physically give the bank the document, right? The bank is going to keep the document as a collateral. Okay, you endorse the document, you say, you know what, the bank is now is able to collect this money in 120 days. And the bank is going to give you a loan of $9,205. Agree? But this is a collateralized loan, so you have a collateral that is given by the IOU. Agree with me? Make sense? Now, there are two situations. Okay. One case, what happens at the end? Case A, bank is fully responsible. So, bank has all risk, has a collection risk. So what is the meaning of that? Imagine that we arrive at the 120th day, the bank has the document and say, okay, Walmart, pay me. And Walmart says, you know what, I don't have money to pay you. I'm sorry, I'm bankrupt. In that case, the bank has nothing to ask you, okay? Because it was an agreement in which the bank says, you know what, once I receive this document, I pay you here, all the risk is with me. Make sense to you? And the second option, the option that is more usual, is that a client, so you, this guy here, has a collection risk. So what is the meaning of that? Imagine that the bank tries to do as best as they can to collect this money. They are not successful. So they are going to knock to your door and they are going to tell you, hey, you know what? The one that was supposed to pay the $10,000 has disappeared. So you need to pay me. And the bank is going to be basically going towards this guy here, towards you. Make sense to you? Now, which one has a higher interest rate? Which one do you believe has a higher interest rate?
A.
Of course. So this is more expensive. Expensive. Okay. Makes sense? Now, of course, guys, the bank is not going to accept an IOU from one unknown corporation. So normally you can do this type of transactions when you have Walmart going to pay you, Apple is going to pay you, or a bank is going to pay you. very, very strong corporation, or a Stop and Shop or Whole Foods that are big corporations. So they accept that what for the banks is important is who is going to pay you here, whose name. So Walmart, I say. Walmart. For example, if it's Walmart, of course, you know, the bank is, for the bank is collect, is perfect. Make sense to you?
Yes, thank you.
Perfect. Okay, guys, questions. Do you have any other question? Nope. Okay, so time for you to work again. Where's my... Okay, so let's do the following, guys. Please, let's use Excel, okay? And you're gonna have 5 minutes to do this stuff, etc. So I want the principle of, let's say you want to buy a house, $500,000. You want the end to be the regular 12 times 30 years. So you're gonna pay this one here in monthly payments, 360. Assume that the interest rate for 1 year, guys, is equal to, let's say, 4.5%. Now this is very cheap in USA. Yeah, let's say 4% per year. Is gonna be your first house. That's all. So what I want from you is compute the payment. I want you to do the payment schedule. Okay, just I want to be sure that you understand this part. Can you do this, please? Second, we have you have an IOU, $200,000. Maturity in 90 days. Settle day. Let's say that it was on 0601. And today is 0608. And you need liquidity. Oh. Okay. You need liquidity today. And bank tells you discount rate, let's assume is 2% per month. So what I need from you guys is how much money you want to receive and bank's discount, how much money the bank is going to keep. Okay, let's say 5 minutes to do this. 5 minutes. Try to do this as quickly as possible. While you do this, I will bring some water. Please, go ahead. Okay, so let's assume the following, guys. I have a loan of $500,000, right? My annual interest rate was what? Can you tell me, guys? Guys.
4%.
4%. So I want 360 months. So my interest rate monthly is this one here. Guys, in USA, the rates are even around 3.15, 3.20% per year. So these are realistic numbers, okay? So basically my payment is going to be $2,366 for a $500,000 loan. And so what I do is I go from 1.3 is 360. It's a lot of periods. Where's 360? Here we go. Then I know my payment is going to be constant. Well, let's do this. My interest is always going to be the 500 times this number here. This is correct. My capital is simply the difference between my payment minus my interest. I have this number that is simply 500,000 minus my capital 729, etc. So I can simply copy all this part here down. And this is what I obtained. So just to be sure, guys, that we have correct numbers is, oopsie. What is this number here? 360 interest cap. Oh, so this is my capital. The EAA, yes, it was wrong because I need to go. Yes, here we go. This number here is equal to this number here, so we are okay. We are safe. So this is my schedule, right, guys? Do you agree? Have you done that? You obtained this one here. When do I use this commission thing here? Let me just copy this part here. So what I will do here is my present value is going to be this $500,000. I have a flat that is 2% of $500,000, so it's $10,000. So my net is going to be $490,000. These are going to be my payments. I put this in negative. So I need to do this up to 360. $360. And the number is the same. And then finally, my internal rate of return. I need to move this up to the end. Oopsie. Up to here. Oh, forget about this. Just ignore this one here. Here we go. So my effective cost of capital, guys, is not 0.32, it's 0.34 versus 4 versus 4.17. And this 2% is diluted, is basically diluted in several times, in several 360 months, so it's a lot. Make sense to you guys? Do you understand?
Yeah.
Yeah, perfect. Okay, so finally, guys, and with this we stop the class, we finish the class. Let's do the discounting here. Okay, in the discounting here, it is basically, I'm saying I settle my document on June 1st. I'm here at June 8th. And I need to compute, first of all, how many days are left. So I'm here. So how many days are from here to here? 7 days, correct? So how many days are left? The days that are left are 83 days. Now, if I want to know the money here, my amount of money is going to be my $200,000 divided by 1.02. This corresponds to how many days? 30 days. So this is the power, guys, okay? Don't get confused. It's not multiplication, it's power. So the power is 30. How many days do I need here? This goes here. Correct? So what do you get here? Someone? Someone can help me here, guys. Guys.
189,337.30.
Point 30. Someone to confirm?
Yes.
Confirm. Perfect. What is my, so this is A, so this is question A. Now B, bank discount. Is simply the difference between the 200,000 minus the 189,337.30. So this equals what? Someone?
10662.7.
Perfect. Someone to confirm?
Yes.
Confirm. That's it. Another notation for our colleagues from South Africa, guys. We use the commas to separate the thousands, okay? And the dots to separate the decimal sign. I think someone also mentioned to use the dot and the comma. Just to be sure that we use comma for separating thousands. Okay, guys, questions? No questions? Okay, so please remember that for next class on Thursday, we are going to do half class is going to be regular class. And then the second half is going to be for our quiz number 1. Quiz number 1 comes up to net present value, net future value, internal rate of return. So everything else that we have done today is going to be part of the second quiz. Got it?
So all the first 5 exercises that we did today. At
Yeah,
the beginning of the
basically
class, that's it. So if we just go over that and change up the numbers and do those.
Yes, definitely. So that's why I'm always paying attention on the numbers to get the exact numbers so you can replicate those numbers. Okay. Yes. Okay, guys. So see you on Thursday then. Have a nice evening. Good night, guys, and talk soon.
Thank you.
Okay. See you guys. Bye bye.